I'm going to say a strong 90-some% of you know how to do this already because it was on the test. But this is going to be kind of a shortcut. So on the test, you saw something that looked like this. Sine of 2a. And you said, hey, I don't know the double angle formula, but I do know the sum of an angle formula. So you rewrote it as sine of a plus a. Then you could use that sum formula to say, well, I can turn that into sine of a times cosine of a plus cosine of a times sine of a, which we could reduce further to 2 sine of a cosine of a, which is now a formula that will always work out that way. Whatever your alpha is, you can plug it in this formula and you will get out what that value is. So if you ever have 2 times a number inside there, then you can now use the double angle formula to turn it into that. But you already did that. Now we can just memorize this formula and not have to worry about doing all this other work on top of it. We're going to do the same thing for cosine and sine to develop those formulas. Cosine's weird because it has 3 different formulas that are possible. It is the hardest one to use in identities. I'm going to tell you that right now. Using these because each one of these are true. So if you picture on an identity, you might have a cosine of 2 alpha, and you may have to look at your right-hand side to decide which one of these 3 roads you want to go down. And in that case, you might have to go down one road, find out it doesn't work, and pick a new way to go. But this starts out verifying, this one starts out the exact same way. You would be given cosine of 2a. And prior to today, you'd have to rewrite that as cosine of a plus a, because we didn't know the double angle formula for cosine until after today. So if I put this on the test, you would have wrote this. Then you would have turned this into cosine a times cosine a minus sine a sine a. Because your alpha and beta are the exact same values. Well, that condenses down to cosine squared a minus sine squared a. And that is one of our identities that's in that bottom left. You can rewrite cosine 2 alpha as cosine squared alpha minus sine squared alpha. This branches out into 2 different directions. So I'm going to put a little branch line over here. Anytime I see cosine squared alpha, I'm allowed to write that in terms of sine squared alpha. Because cosine squared alpha always equals 1 minus sine squared alpha. So if I ever needed to get rid of this cosine, I could by just replacing it with 1 minus sine squared alpha. And that's exactly what we're going to do. We're going to replace that cosine squared alpha with 1 minus sine squared alpha. And we still have that minus sine squared alpha on the outside. I should say a, not alpha. Well, negative sine squared a minus sine squared a is just 2 sine squared a. So we'll have 1 minus 2 sine squared a. So that's our option if we ever need to write cosine 2 alpha in terms of just sine. Say you're doing an identity and everything on the right-hand side is all sines. This would be the way I'd pick. Because it gets rid of the cosine and automatically goes to the sine. Let's say everything on the right-hand side is cosines and I just want to focus on the cosine. Well, we're going to replace this sine squared a with 1 minus cosine squared alpha. So that's just going to equal cosine squared alpha. I keep saying alpha, but it's actually just a. Minus quantity 1 minus cosine. That's not cosine, that's sine. Cosine squared a. When I distribute this negative sign, we're going to have a negative 1 and a positive cosine squared. That's why we're going to end up with 2 cosine squared A minus 1. That is my third possible way to write it. And all three of those ways are equal to each other. So cosine 2 alpha equals cosine squared minus sine squared equals 1 minus 2 sine squared equals 2 cosine minus 1. All of those are all equivalent to each other. All right, so you can go down any path you want to on these problems, and you may have to adjust your path to see what's going on the right-hand side. All right. We're just watching brief text real quick. All right. Did you get the text out? Okay, I was just making sure. I was worried. Must have been important. All right. This one's going to start out the same way. We're going to have tangent of 2 alpha. After today, let's not make it alpha. Let's make it A.
What's the difference? I'm like...
It is variables.
These are just variables. Alpha is the same as A. It's just a variable. It's just like x's and y's. It's just x's and y's. Alpha usually holds the place and beta holds the place of an angle. X and y usually hold the place in algebra.
But now it's A.
A is just, it's just like x and y. I just picked a new variable.
Okay, cool.
So the whole goal is that I can keep moving between letters and you don't. So I could put a B there. I could put tangent of 2b and it wouldn't throw you off. That you know B is just a placeholder for a number. So A is just a placeholder for a number. Alpha is just a placeholder for a number. So these two formulas are the exact same, even though these have A's and these have alphas in them. It's the same exact formula. All right, so I have tangent 2A, which you would write as tangent of A plus A, which is then going to equal, using that formula, we'll have tangent of A plus tangent of A all over 1 minus tangent A times tangent A. That's a formula you should have memorized for yesterday's test. Well, let me just, I have 2 tan A on top. And on bottom, I have 1 minus tangent squared A on bottom. Sine and tangent are usually the easy ones to deal with on double angles because there's just one formula. Cosine can be a lot more difficult because there's 3 different ways you can go with it. And we'll see that tomorrow because we're going to start doing identities tomorrow with these. Today is just basically plug and chug day. All right. Find the following with the double angle identities. What's the sine of 120 degrees equal? Oh, you don't know it? What was that? It's square root of 3 over 2. We know the answer to this. So we should get square root of 3 over 2 when we are done, correct? Because we know using the unit circle. But this says I specifically have to use the double angle identity. To use the double angle identity, this has to be written in the form sine of 2 times a number. So we'll say 2 times x.
It has to be like always like 2.
If it ever asks for a double angle, it has to be 2 times something. Because if we look at all of our identities, it is tangent of 2 times a number. Cosine is cosine 2 times a number. So if they ever ask for the double angle identity, you have to have 2 times some number. But what's in here has to equal 120. So I'm basically just factoring out a 2. I have 120 and I'm factoring out a 2, and factor just is a big word for divide out. So I'm dividing out a 2. I'm pulling out half of this. So we are going to rewrite this as sine of 2 times 60, where 60 is that x, that alpha, the A. This 2 is not actually put into the formula. This 2 just tells me to use the double angle. This 60 is what's important. This 2 just tells me, hey, go to my identity sheet that I'll have for my test. Go to sine of 2 alpha. Oh, here we go. I'm going to use this formula. Where in the case that's right in front of you, this alpha is 60. So we're going to replace all of these with 60. So you're just going to have 2 sine cosine. So this is going to equal 2 times sine of 60 degrees times cosine of 60 degrees. Well, sine of 60 degrees is going to be square root of 3 over 2. Cosine of 60 degrees is 1 over 2. Simplifying that further, we're going to have 2 times, square root of 3 times 1 is square root of 3, over 2 times 2, which is 4, which is then going to equal square root of 3 over 2, which, as Safa said, we already knew that answer. We're just confirming that this, in fact, works. So the double angle formula can help you get values that aren't. 120 is on the unit circle. I just want to make sure you had a value that you trusted and it actually worked. But there are some times where it's not on the unit circle, and using the double angle can put it on the unit circle. All right, do the same thing for cosine of 120. Well, cosine of 120, we can't use this double angle. Says I need to have something that's 2 times x in there. So we're going to rewrite this as cosine of, has to be the same, 2 times 60. It's got a different formula, right? And I'll go back to it. You have 3 choices. You can either use cosine squared of 60 minus sine squared of 60, or you could use 1 minus 2 sine squared of 60, or you can use cosine 2 times cosine squared alpha minus 1. You can use whatever one you want on there, and I highly suggest just pick one. I'm going to pick the cosine, just because I did in the other class. I'm going to use the cosine squared minus the sine squared, but if you want to try another one, go ahead. But I'm going to do the cosine squared of that 60. Remember that 60 is my placeholder. That's actually my x value. So we'll have cosine squared of 60 minus sine squared of 60. Well, cosine of 60 degrees is 1/2, and we have to square it. Minus sine of 60 is square root of 3 over 2, but we have to square it. Moving down, 1/2 squared is 1 over 4. Minus square root of 3 squared is just 3. Over 2 squared is 4. That's going to equal 1 minus 3 is negative 2 over 4, which equals negative 1/2. Yeah, Emma.
What did you ever do to the 2 when you did 2 times 60?
I did nothing with the 2.
Why?
All the 2 says is use your double angle formula. So that 2, the only purpose of it is to point you to using one of these formulas. All right? And then the 2 is already involved in this.
Yeah.
All right, as we showed here.
Yeah.
So the 2 didn't necessarily disappear. It's just we worked it out to have a formula that we can quickly get to that answer.
Yeah.
So don't ever use that 2. That's why I said this 2 kind of disappears once I use the formula. It looks like I had the 2 there, but that 2 didn't come from here. It just came from the formula.
Oh.
This 2 directs me to use this formula. All right, same thing with this this tangent. We're going to do tangent of 2 times 60. I'm not actually using that 2. I'm using that 2 to point me towards which formula to use. And that it's 2 times an angle, so that means use your double angle formula. So that 2 is always going to be there if we're using double angle, which is going to be 2 tangent over 1 minus tangent squared.
You just pull the 2 out of it.
You don't,
You like, okay.
the 2 kind of disappears, right? This 2, all it does is tell you to write this. The 60 is the important part. The 2 tells me to look at this formula. The 60 tells me what to plug in for this alpha.
Oh, okay.
Okay?
Yeah.
So these are both going to be 60. That 2 just tells you to use this formula. 2 is your direction. 60 is actually the term that you're using. You're using that 60. All right. So 2 just tells me to look at that on my identity sheet and then type in 2 times tangent of just the 60. Just the 60. And it's all over 1 minus tangent squared of the 60. So we're not putting that 2 inside here with the 60. 2 is just your direction. 60 is actually the tool you're using. All right. Who knows the tangent of 60 degrees? It's a nice one. It's not the best one, but it's a nice one. Yeah.
Square root of 3.
It is square root of 3. It goes square root of 3 over 3. Then your next tick mark is 1, which is the best one, and then a square root of 3. So we're going to have 2 times the square root of 3 over 1 minus the square root of 3, but it's squared, so we don't have to worry about using the conjugate. Which, surprisingly, this class did really well in using the conjugate with the tangent stuff. This class did really well in that portion of it. I didn't say you, I said this. No, I'm just kidding.
Are you saying the other class did?
Yes.
Yeah.
All right, so that's going to equal 2 square root of 3 over 1 minus 3, which is going to be 2 square root of 3 over negative 2, which at the end is going to equal negative square root of 3. Let's really quick think about these answers and see if they make sense. They're right, but let's just on the surface of the numbers just determine if they make sense. Which quadrant is 120 in?
2.
Quadrant 2. Should cosine be positive or negative in quadrant 2? And it's negative.
Whoa.
Should tangent be negative or positive in quadrant 2? Yeah. And it's negative. So on the surface, we can do that quick check and go, okay, things are looking right. So using this formula will actually get you to your right, negative, and positive. You don't have to really worry about your quadrants. All right, the next 3 are...
Wait, I have a quick question.
Yeah.
So it's like the same on what did we get in the unit circle though? So if we don't get this as the answer, then we got it wrong, right?
Yeah, if when you're doing your double angle, this isn't on the unit circle, like 60 is on the unit circle,
Okay, so cosine 120
is on the unit circle.
yeah, it's negative 1/2.
But on the test, it might be something that's not on the unit circle, and using the half angle will actually put it on the unit circle.
Okay.
All right, so one offhand is maybe 70 degrees. 70 degrees is not in the unit circle, but 2 times 35 would then be on the unit circle.
Okay.
Or 30, I should do 30. Anyway,
Yeah.
so it'll help put it on there. Okay, so our next one is our half angle identities. There are a way to verify this. I'll print it out tomorrow and you can look at it, but we're not going to actually verify all of them. They're true, believe me. All right, these are all correct. Once again, you are going to have a number over 2. You don't actually use this 2. You just use that 2 to direct you to which one of these you're using. So our first thing is find cosine of pi over 8. Pi over 8 is not on the unit circle. Pi over 8 is not on the unit circle. So this would be a good sign that we have to use either the half or the double angle. And these are going to be our half angle formulas that we're going to use. So we need to rewrite this. Instead of cosine of pi over 8, in order to use our half angle identity, you have to have cosine of some number over 2. But this fraction needs to equal pi over 8. And how we're going to rewrite this is an ugly fraction. We're going to write this as cosine of pi over 4 divided by 2.
Yeah,
We don't agree that's right?
No,
No,
just
we
don't
just
know.
Oh, how do you do it on your own, like with fractions?
Yeah.
That's what we're going to talk about right now. It's not as easy as it looks. So first of all, let's make sure it's true. Let's first make sure it's true so we all agree it's true. So pi over 4 divided by 2 is pi over 4 times the reciprocal of 2, which is 1 over 2, which equals pi over, not 6, 8. So it's true. It is true. Pi over 4 divided by 2 is pi over 8. Yes? No, I'll describe my thought process behind it.
No, I'm just don't understand where you're getting the pi over 4. I get that it's true. Like, how do you get that in the first place?
Yeah, so the easiest way... So we know something over 2. All right, and when you have a fraction divided by 2, this fraction is always going to multiply the bottom of this fraction. So, for example, let's say I have pi over 7, and I need to rewrite it as something over 2. I need to half this.
Oh, okay.
So it would be pi over 3.5. And you half it because this would be pi over 3.5 times 1 over 2, writing it out. So you are just going backwards. So that equals pi over 7. Do we agree this is true? That pi over 3.5 divided by 2 equals pi over 3.5 times 1/2 equals pi over 7. All right, you just have to go backwards. And to go backwards, you're going to take your 7, divide it by 2, which equals 3.5, which gets you your 3.5 on top.
So you should do next.
So if you have fractions, the easy way to put it over 2 is just divide your denominator, which is 8, by 2, which gives you 4. Another example. Let's say I have pi over 16. It would be pi over 8 divided by 2. If I had pi over 14, that would equal pi over 7 divided by 2. Does that make a little more sense where you can do it on your own? Just be aware it's true. It's true, and it's the quickest way is just divide your denominator by 2 and then put it over 2. Okay, let's move forward. So now I have a number over 2. This 2 here only directs us where we need to go. So that must be a half angle identity. Now we pick which one we're using. Well, we're using the cosine half angle identity, which is plus or minus the square root of 1 plus cosine over 2. So we're going to rewrite this as plus or minus the square root of 1 plus cosine. Now here's where this gets tricky and people forget about it. This 2 only directs me to where I'm going. I am just using that pi over 4. I am just using that pi over 4. That is the most important part. That is my x value. So that is the value that's going to go there. So I am just using that pi over 4 over 2. All right, that's going to equal plus or minus the square root of 1 plus, well, cosine of pi over 4 is square root of 2 over 2. Over 2. Now, we've been training for this.
Weren't they just over 2 before?
Just took cosine of pi over 4.
Oh.
I just took cosine of pi over 4. There's a hard way to do this and an easy way to do this. Hard way is turn this into 2 over 2. Then have 2 plus square root of 2 over 2 over 2. Keep, change, flip. Sounds like a lot of fun.
Why are there so many 2?
But rather than doing that, I'm going to multiply my numerator by 2, which means I have to multiply my denominator by 2. That will clear out those fractions. You have to remember to distribute the 2 to everything. So that's going to equal plus or minus the square root of 2 plus square root of 2 all over 4, which simplifies down to merely square root of 2 plus square root of 2 all over the square root of 4, which is 2.
That was the easy way.
Is it plus or minus? Which one?
I don't know. That's what we have to decide.
Oh.
Wait, how did the 4 change to a 2 all of a sudden?
What's the square root of 4?
Oh.
It is not 21. So there is an intermediate step if you need it. This would be square root of 2 plus square root of 2 all over square root of 4, which gives me that square root of 2. Now I have to decide if it's plus or minus. We have to know if it's plus or minus. Mary?
Would it be positive because if pi over 8 wasn't it, would it be quadrant 1?
Yeah. Did you guys hear that?
Yes. Quadrant 1.
Pi over 8's in quadrant 1. So our answer needs to be positive. So pi over 8, that's quadrant 1. So that means our answer needs to be in quadrant 1. So it needs to be positive because we're in quadrant 1. Yeah, Emma.
So is it the square root of the square root of 2?
Yeah, that's as far as you can simplify it. You can't go any further than that.
But like, that's okay.
It's the square root of 2 plus square root of 2.
So what is the square root of the square root of 2?
Well, it's the square root of a quantity 2 plus the square root of 2. You can't break apart a square root.
No, but I'm just saying.
Yes.
It's
Yeah, there's a
still-
square root under a square root.
Oh, okay.
Yep, and there's no way to simplify it.
Okay. Cool.
Yes.
Would that make the 4 root, whatever it's called? Exponent.
It would be, but there's no way to distribute it. So it is. If it would be the square root, if it was just the square root of 2, then it would be 2 to the 4th root. Yeah. But we're not going to go that far. We're just going to leave it as is. All right, let's do this again. All right, the only hard part of these problems should be writing it. This needs to be sine of some number divided by 2. These are a little easier because it's just 150 divided by 2. You just double it, right?
Wait, so why do you...
What was that? Who asked why I had to double it?
Yeah, why do you...
Because what's 150 divided by 2? These need to be both equal. These need to be both equal. 150 divided by 2 equals 75. Yes,
How do you know when to use half angle and double angle?
I'll tell you.
Oh. Like, on the, you'll tell it? Oh, okay.
I'll say simplify these, and I'll say like hint to use half angle or hint to use double angle. All right, so you'll know.
Oh, would you look at that?
All right. So we now have 150 divided by 2 because it's the same thing as 75. Now, real quick, everyone pay attention to this. I just doubled this value up here. That is, in fact, what we did here. 2 times pi over 8 is pi over 4. So you are always doubling it and putting it up there. It's just sometimes easier if you just half the denominator. But you are just doubling it and putting it up there. All right, so we have 150 divided by 2. The 150 is the most important part. That is my x value. That 2 just tells you to turn the page back and find your sine half angle identity, which is the exact same thing as my cosine one, except there's a negative in there in its place. So we are going to have this all is going to equal plus or minus the square root of 1 minus cosine
Oh, cosine?
It's still cosine.
Oh, yikes.
There's not a mistake on here. There's not a mistake on here. It's weird, right?
Yeah. There's not.
It is still cosine, but this time it's a minus cosine of my x value, which is 150. So we use whatever's in that x value, so that's 150 all over 2, which equals plus or minus the square root of 1 minus, well, the reference angle of 150 is 30. So there's going to be a negative square root of 3 over 2. All over 2? Yeah. Sure. All right, but that's just going to be plus, right? We have a negative times a negative would just be a plus. And to get rid of that fraction, I'm just going to multiply the top by 2 and the bottom by 2. And that's going to equal plus or minus the square root of 2 plus the square root of 3 over 4, which is just going to equal the square root of 2 plus the square root of 3 all over 2. Note 75 degrees is in quadrant 1. So that means I'm going to use a quadrant 1 positive or negative. Well, sign is positive in quadrant 1, so it's going to be a positive because we are in quadrant 1. The only real hard part about these half-angle identities is A, getting that value correct that goes in your numerator, especially if it's fractions. And B, don't plug this 2 in here. Everyone look at the board real quick. Don't plug this 2 in here. This just tells us which function. You laugh, but 5 of these people in this classroom are going to plug this 2 in here. They're going to plug in pi over 4 divided by 2, and they're going to have pi over 8 in here, and then they say it's not on my unit circle. This 2 just tells you to use this formula. Use that top value to plug it in. I can't say that enough because it's going to keep happening. And look at everyone laughing. And I'm telling you, 4 or 5 of you in this class will plug a 2 in there and not know where to go. All right, the rest of the time is yours to work